Hello everyone, welcome to MATHFREAKS. So today we are going to discuss the part 2 of our basic maths. So let's begin. First of all, I want to start by correcting a mistake that I did in the part 1, that is in the rules of modulus function. In one rule I said that mod of x plus minus y is equals to mod of x plus minus mod of y for x greater than 0. So this is obviously wrong. Okay, so I was a bit nervous and as a result I did some mistakes, so this is totally wrong. Okay, so in that place write the correct rule, that is mod of x plus mod of x plus y is equals to mod of x plus mod of y if and only if x and y both are greater than or equals to 0. And this makes sense in a way, right? This is pretty obvious, right? If we take all the numbers greater than 0 or equals to 0, then this identity or this equality will be true. But if we take any number less than 0, then it may not it is not true, right? For example, okay, so I'm talking about mod of x minus mod of y now. So we cannot write this as mod of x minus mod of y if and only if x and y greater than 0. This is only this condition is not enough for this rule. Why? Because see, if I take x as 2 and y as 5, so this will be, we will get 3, but from here we'll get 2 minus mod of 5, that is as usual, so we are getting here minus 3, so this equality is not satisfied. That's why only this condition that x and y both has to be greater than or equals to 0 is not enough. One condition we have to add in here, that is x has to be greater than or equals to y. This is the second condition for this equality being true. Very logical. Think of it like if I take an example, say 5 and minus 4, so from here we are getting what, 1, and from here as well we will get 1. So we see that this equality is satisfied. So for the first condition, that is x plus mod of x plus y is equals to mod of x plus mod of y, this equality is only true if and only if x and y are greater than or equals to 0. And for the second one, that is x minus y, it is equals to mod of x minus mod of y if these two conditions are satisfied. So it is very important to understand the conditions and why we have applied it. Okay, then let us move on to the next rule, that is mod of x square is equals to x square, sorry, mod of x whole square is equals to x square. Again, very logical example, say minus 2 mod whole square is equals to 4, and similarly minus 2's whole square is also 4. So you see, you can take any number and this condition is always true for any values of x. There is no condition. And another rule you can say, it comes from here only, that is mod of x is equals to root of x square. Okay, this is you can say this is another rule that comes from this part only. Okay, so I hope that these three rules are clear to all of you. Now let us move on to the graph of modulus function that we missed in the first part. So graph is pretty simple, so we are going to draw a graph for y is equals to mod of x, right? So this is your x-axis and this is your y-axis. Now this is pretty simple. This will be see, this is the graph of y is equals to mod of x, and this angle is 90 degree, and here y is equals to x and here y is equals to minus x. So here, as we said, that whatever we put in between the mods, we are always going to get the positive value of that quantity. So here also it is very clear that if we take any, like if we take negative quantity for x, we are always going to get a positive quantity for y. See, we are always going to get a positive quantity for any negative quantity of x, and here since it is positive, so obviously we are also going to get positive value here as well. So this graph is also an explanation, you can say, uh, that mod of x is always positive. See, I hope you understand. I'm telling that if you take any negative value of x, then also you are going to get the positive value of y. See, because see this one, correct? So you're always going to get a positive value of mod. So I hope that this graph is also clear to all of you. Graph is not necessary, I'm just showing you to for your interest. Okay, now let us move on. Now we have talked about equality, right, a lot. Let us practice two or one questions from here. So the first question that I want to discuss is, say, x minus mod of x minus 1 plus mod of x minus 5 is equals to 3. Okay, so in the first part we discussed one type of questions, and now we are going to discuss a new approach for these questions. So try it out. If you can't, then we will move on with our solution. Done. Now let me show you my solution. Okay, for this type of questions you have to make cases. Okay, so how to make cases? It is like wavy curve method only. First of all, what you have to do is equate the mods to 0. Okay, equate the modulus functions to 0. Like in the wavy curve method we equated the factors to 0, and in this case we have to equate the mod to 0. So if we equate this to 0, so we will get critical points. From here we are getting two critical points, that is 1 and 5. So what you have to do is you plot this in the number line. Okay, so this is your number line, plot 1, and here plot 5. Now what you have to do is you have to make cases. How? Let us see how we will make cases. First of all, what I will do is I will take x greater than or equals to 5. Like I am taking x, the value of x in the region, in this region. Okay, in this region. So case 1 is x greater than or equals to 5, this case. Now have a look at the equation. We are taking x greater than or equals to 5. So can you tell me what will be the value of this mod for case number 1? This mod will be always positive, right? Always positive. X minus 1 will be always positive for this case. Since it will be always positive for this case, we are going to open the mod without any sign change. That is, we are going to write as it is x minus 1. Now let us come to the second mod, that is x minus 5. Here also, since we have taken x is greater than or equals to 5, this mod will also be always positive. Okay, so since this will be also positive, we will open this also without any sign change. So this will be x minus 5 and this will be equals to 3. This is, I'm talking only for case 1 where we have put a condition that is x is greater than or equals to 5. So if you solve this one, you are going to get x is equals to 9 by 2. Correct? X is equals to 9 by 2. Now let us move on. Now we have done this region. Now let us take another region. I will take now x less than 1. X is less than 1. I'm taking case number 2. X is less than 1. Now if for case number 2, look at the mods and tell me how will we open the mods. It is pretty obvious that since x is less than 1, this quantity will always be negative. Correct? See, I am talking x less than 1. I am not talking as x less than or equals to 1. Okay, I have not taken that. So remember, I am talking only about x less than 1. So this one will always be negative. Okay, so if this one is always negative, so we have to open it with a negative sign. So this will be a minus of minus of x minus 1. Now come to this mod, x minus 5. Since x is less than 1, this all will also be negative always, so this will be also negative of x minus 5 is equals to 3. Now I hope that you understood this condition. Since we have taken x less than 0, always remember we have taken x less than 0 and we are talking only for this case only. Okay, so this will be minus of x plus 1 minus of x plus 6 is equals to 3. So minus 2x is equals to minus 4, or x is equals to 2. Correct? Minus 2. Okay, this will be 5, sorry. Plus 5, so 6 minus 3, so this will be 3 by 2. Correct? Now let us move on to the third case, that is x is lying in the region of, in this region. Now in this region, now it is very important, this case is very important, this is the main case. Okay, now how to take the condition for this case? See, for one case we have taken x is greater than or equals to 5, and for the second case we have taken x is less than 1. So for the third case, can we take x, x is greater than or equals to 1 but less than 5. Now why we have not taken x is also less than or equals to 5? Because we have already included 5 in this case. So if we again include 5 in this case, then it will be a repetition of cases and the answer will not be correct. Here we have included 1 because in the second case we haven't included 1. So if we include 1 again, so this won't be a repetition of case, but if we exclude 1 again, we are missing one case, right? So this is how we have to take the case 3, that is in this region. So again, see, x is now greater than or equals to 1. So for the first, this one, since x is greater than or equals to 1, this one will be always positive. So this will be x minus 1 without any sign change. And for this one, this will be always negative because x is lying in between the range of 1 and 5. So x minus 5 will always be negative. So this will open with a minus of x minus 5 sign is equals to 3. So we see that we are getting 4 is equals to 3, that is obviously, so this case is wrong. So we can assure that x will not definitely lie in this region, right? This is for sure. Now we have got two values of x. Now are we done? No, right? In the previous lecture I have told you that after finding the values of the mod, you have to put the values of x in the equation, original equation, and then you have to check if the value satisfies. Now it is your homework to check if these two solutions satisfy this equation, and if not, then what we can say that this equation has no solution. So I hope that you understood the solution to this question. This is another approach. In the first lecture we showed you questions with a specific approach, and now this is another approach. Correct? Now I will give you one question, another question from the same approach, that is mod of x minus 1 plus mod of x minus 2 plus mod of x minus 3 is equals to 5. Okay, this is another question. I will give you this as homework. Same approach, try to solve this with the same approach as I showed you. Okay, this is your homework. Now up to here we are done with the equality in mods. Now we are going to begin with the inequality in mods. Okay, inequality in mods. So let's begin our new topic, that is inequality in mods. Modulus function. Okay, now I will show you with an example. Okay, say if I give an example of x is greater than or equals to 2. This is an example. Okay, now you are asked to find the range of x. Okay, you are asked to find the range of x. Now what is the range of x? What do you mean by range of x? Or range of x means like set of values, like a region in which if you take any value of x in that region, it will satisfy this inequality. Okay, a range is that if you take any value of x in that range, your inequality will be satisfied. That I mean by range. Okay, so if anybody asks you to find the range of this inequality, okay, range of this inequality, now how will you find this? Okay, see, it is given us that x is greater than or equals to 2. Okay, so first of all, one simple thing comes to my mind. If x is greater than or equals to 2, then we can definitely say that one range will be from 2 to infinity. And I hope that you understand these notations, because in the first lecture I told you everything about these notations. Okay, so we have included 2 and excluded infinity. Obviously, why included 2? Because this x can also be equals to 2. Okay, wait, sorry, this will be mod of x is greater than or equals to 2. Okay, sorry, mod of x is greater than or equals to 2. Now one range we have got, this x belongs to 2 close to infinity. Now since we are talking about modulus functions, we have to also consider the negative values of x. Now tell me one simple thing. If I take x as minus 2, will this equation be will this inequality be satisfied? If I take x as minus 2, if I take x as minus 2, mod of x will obviously be 2, and this inequality x can also be 2, so this inequality is satisfied. Now tell me minus 6, mod of minus 6 is 6, so x is equals to 6, that is greater than 2, so again this inequality is satisfied. Now can we say that if we generalize this a bit, can we say that x will also have a range in the negative range of negative values from minus infinity to minus 2? We have to include minus 2, obviously, right? Can we say that? Because if you take x as any negative value, you are always going to get a positive value, right? That is mod. So we are getting one range of x as this one, and the another range is this. Okay, so what we can finally write, x belongs to minus infinity comma minus 2 closed union 2 comma infinity open. If you are not understanding these notations, please watch the previous lecture. I have explained these notations. Okay, so I hope you understand that this was pretty obvious, this range was pretty obvious, but you have to think about this one also, right? Because since we are talking about mod, we cannot neglect the negative values of x. Okay, so I hope that this one is clear, this inequality is clear. Now if I just reverse this, and if I ask you to find the range, now you guys do it, find the range of mod of x less than or equals to, say, 3. Less than, I'm talking about less than. Try to find this. Done. Now let's see what we can do about this. Okay, so since mod of x is less than or equals to 3, one range that is pretty obvious is 0 comma 3 included. This is a pretty obvious region, okay, where x can belong. But another region you also have to take in mind is from -3 to 0 also. This range will also satisfy this inequality, right? Because if you take -3, you're always going to get 3. If you take -2, you're going to get 2, right? If you take -1, you're going to get 1. So from -3 to 3 included, they both are included in this range. All the values of x will satisfy this inequality, correct? So we can say that x belongs to this will be included -3 comma 3 closed, okay, closed brackets, correct? So I hope that you understood these two inequalities. Now if you have understood these two inequalities, let us check if you can find the range of x for this inequality. Mod of x is greater than, say, 4. Okay, try to find the range. Done. So again I'm telling you, since x is greater than 4, x cannot be equals to 4. So again the obvious region is x is belonging to 4 comma infinity. Now we cannot write the closed bracket because here the inequality is saying that x cannot be equals to 0, correct? X cannot be equals to 0. So this was our obvious region. Now again for the negative values as well, this inequality will be satisfied, but from which range? From -infinity to -4, and again open, right? Because x can never be mod of x can never be equals to 0 according to this inequality. So finally we can write that x belongs to -infinity comma -4 union 4 comma infinity, correct? This will be our range for this inequality. Again now you can again find the, say, this one, this range you can also find. I'm directly writing this, okay? Sorry, mod of x less than 4, so this is very obvious. This will be from -4 to 4 open because not included, correct? So this was your inequalities. Now I have explained this with some examples. Now if you want to generalize it, okay, so if you want to now one thing that we can say, if asked mod of x is greater than, okay, we'll leave that. If you want to generalize it, what we can say, if mod of x is greater than or equals to a, greater than or equals to a, so x will belong to -infinity comma -a closed union a comma infinity. And you can find for x is less than or equals to a, you can find for this one. So this is your homework, very easy. And if asked that mod of x is greater than a, again x belongs to -infinity comma -a union a comma infinity, correct? And you can also find for this one, say, homework, correct? So I hope that you understood the inequalities that we talked about. Okay, now let us practice a lot of questions from these inequalities so that your whole conception about modulus function would be clear. At least up to Prmo level it will be clear. Okay, first question is easy, very easy. This one, mod of x square minus 5x plus 6 to 0. Try to solve this equality or this equation. Done. Now let us begin with our solution. Okay, now this one is see, this equation is equals to 0. One thing that we can say that we have been I have been telling you is mod of x will always be a positive quantity, now see, mod of some quantity is added with the mod of another quantity and their sum is equals to 0. See, if you add, now this will always be positive because mod, this will always be positive because of mod. So when will be the summation of two positive quantities equals to 0? When both the quantities are 0. I hope you understand, because mod of any quantity is positive, so this one will always be positive or greater than or equals to 0. Like this one will be greater than or equals to 0, this one will also be greater than or equals to 0, and the two positive quantities are added and their addition equals to 0. So this case is only possible when both the quantities are equals to 0. Correct? I hope I am making sense right now. Two positive quantities, if their addition is equals to 0, this is only and only possible when the quantity is 0. Okay, so simply you can say that, or if you want to write a statement, you can write that since only possible cases, they are both are equals to 0. Okay, correct. Now if you just solve for this equations, you are going to get the values of x. So x square minus 3x minus 2x plus 6 is equals to 0, or x minus 3 and x minus 2, correct, is equals to 0. From here we are getting two values of x, that is 2 and 3, and from here what are we going to get? X square minus 6x minus 2x plus 12 is equals to 0. Correct? Okay, so from here we are getting x is equals to 6 comma 2. So solutions of this equation is x is equals to 2 comma 3 comma 6. So three solutions of this equation, right? Okay, so I hope that you understood you have understood this whole question. This was very simple question. Now let us level up a bit. This is again a similar kind of question. This is the question that, this is like the first question, same approach. Try to solve it, you can solve it, I know it. Done. Now let us begin with our solution. Again you have to equate the mods to 0, so we are going to get two critical points. So put it on the number line 1 and 2, correct. Now again make cases. First region is x is greater than or equals to 2, case 1 for this case. Okay, x is greater than, for this case this one will always be positive because x minus 1, and we have taken x is greater than or equals to 2, positive. This one also positive, so x minus 1 minus x plus 2 is equals to 10. So obviously 1 is equals to 10, so x will x will definitely not belong to this region, correct? This region is not where the values of x will lie. Now the second case is x less than 1. Second case is for x less than 1. Again you have to look at the mods. This one will always be negative since x is less than 1. This one will also be always negative for x less than 1, so both of them will open with a negative sign, correct? So if we do this, so this will be minus of x plus 1 plus x minus 2 is equals to 10. So again this is so x will also not lie in the region less than 1. So now the final case number 3 is this region where we have to be very careful while taking the region. So this region, how we have to take is x, since x we have not included 1 here, so we have to include 1 in this case, and since we have included 2 in this case, so we have to exclude 2 in this case. Okay, so this one positive, this one negative, correct? So if this is the case, so x minus 1 plus x minus 2 is equals to 10. So 2x is equals to 13 implies x is equals to 13 by 2, correct? So I hope that you understand this one. Since x is belonging to from 1 to 2, so the first mod will always be positive and the second mod will always be negative. So we have to open the x minus 2 with a sign change, and this is the your solution. Now check for x is equals to 13 by 2. If this satisfies, then this is the solution, correct? So I hope that you have understood this question as well. Now another question we will discuss. Question is 4x to 1. This one very simple. Try to solve this. Done. Now let me move on with my solution. Okay, now again this type of question we have discussed in the lecture number 1. That is, we will take we will write this as now this like so 3x plus 2 can either be equals to minus of 1 minus 4x, or can either be equals to 1 minus 4x, right? Correct. So if I write mod of x equals to some y, so y can either be minus of x or y can either be x, and this we have seen also in the graph as well, right? See, I'm showing you the graph once again. See this graph. If we draw the graph of y is equals to mod of x, y there are two cases. Y can either be equals to minus x or y can either be equals to x. See, correct? So we can have two cases. So solve for both the cases. Okay, I'm solving for 3x plus 2 is equals to minus of 1 minus 4x. This one will be 3x plus 2 is equals to minus 1 plus 4x. So we are going to get x is equals to 3. Correct? Case 1. And for case 2, we have 3x plus 2 right is equals to 1 minus 4x, or we have 7x is equals to minus 1. We have x is equals to minus 1. So there are two, so we have got two solutions, right, from the two cases. So now you have to check which values will satisfy the equation, or both the values can also satisfy the equation. That is your job to check. Okay, so this question was also very easy. Now one question again, another question from mod only. That is very interesting question. So the question is 12 minus 2 of 2 multiplied by 2x minus 3 is greater than or equals to 7. Correct? So 12 minus 2 multiplied by mod of 2x minus 3 is greater than or equals to 7. Now let's solve this one. If you know a bit of inequality, you can solve this, and if you don't worry, I will talk about that inequality part in this question. Okay, done. Now let's begin with my solution. If you were not able to solve these questions after this lecture, download the PDF note of the session and try to solve this question without looking at the solution. Okay, now let's begin. So again, minus of 2x minus 3 is greater than or equals to minus 5. Now one thing that I want to make clear is, if I say minus of 2 is greater than minus of 5, correct? Now if I like, what you do is, if we find an inequality like this, equality like this, say mod of x is equals to, minus of x is equals to minus of y. So what we do is, we multiply both the signs, both the sides with a negative sign or -1, then we get x is equals to y, right? Now but for an inequality we cannot do so. Okay, we cannot do so. Why? I am showing you with an example, this example. So if I say minus of 2 is greater than minus of 5, and then we cannot, then we can obviously multiply both the sides with -1, but for that we have to change the sign. We cannot write it as -1 multiplied by -2 is greater than -1 multiplied by -5. Correct? Why? Because if we write this, then we are writing that 2 is greater than 5, which is not true. So if we find an inequality like this, minus of x is greater than minus of y, so for the positive values we have to change the sign as well. So this will be x is less than y. I hope that you understand. You look at this example and look at this example, relate the things, you will get your answer. Again, for example, if I say minus 4 is say less than 5, Okay, and if you change the signs, then you have to also change the inequality. That is, if you want to change the sign, then you can write 4 is greater than -5. But if you don't change the inequality, this will be 4 is less than -5. That is not true. So you have to also change the inequality sign if you change the signs of the RHS and the LHS. So similarly, I have explained all this to explain you this one, that I am going to write it as 2 multiplied by mod of x minus 3 is less than or equals to 5. Now why equals to? Because I have told you, if I say mod minus of x is equals to minus of y, we can then write it as x is equals to y. But for the inequality, we have to change the sign. Correct? Now if you change the sign, now we are getting at mod of 2x minus 3 is less than or equals to 5 by 2. Now how you will solve it? Now to solve this, you have to look back where I explained you the inequalities. This one now will be extremely useful for you to solve this question. How? Let's have a look at this. So I am telling you, if you take it as t, so mod of t is less than or equals to 5 by 2. So how can you write this? So you can write it as t belongs to minus 5 by 2 to 5 by 2. Correct? That is what we have done in this section. See, in this portion, right? So if mod of x is less than or equals to 3, then we have got the range as x is belonging to minus 3 to 3. Similarly here, t is less than or equals to 5 by 2, so t will belong from minus 5 by 2 to 5 by 2, where both the extremes are included. So if you replace the value of t here, what you're going to get is 2x minus 3, correct, less than 5 by 2. Okay, now what you can do is solve the inequalities now. Okay, many of you may not know how to solve this type of equation, or sorry, inequality. So let me show you. If I have x minus 3, or not, say minus 2, so how to solve this? Now we are asked to find the range of x. So what we will do, we have to eliminate 3 from here. Correct? We have to eliminate 3 from here, so we have to add 3 here. So if we add 3 here, then we have to add 3 both the sides. So the range will ultimately be, or because x belongs to 1,4 included. So this is how we solve such type of equations. So similarly, inequalities. So similarly here also we have to eliminate 3. So add 3 both the sides. Correct? Now if you add 3 both the sides, so half and 11 by 2. Now we are asked to find the range of x, not 2x. So we have to eliminate 2 from here as well. To eliminate 2, we have to divide it by 2. Since we have divided it by 2, we have to divide both the sides by 2. So finally, after all you do all of this, you are going to get the range of x is 1 by 4 to 11 by 4. So you can write x belongs to included 1 by 4 comma 11 by 4. Correct? I hope you understood this whole question. Very interesting. The things that you may not know, I have discussed it. That is the inequality sign change and how to solve this type of inequalities. Correct? Now Say another example. Now solve for x, find the range of x, or let me, okay, now find the range of x. Done. Now how did you do this? You have to eliminate -1, so we have to add 1. So in order to remove 1, sorry, -1, we have to add 1 both the sides. So this will be something like this. Correct. Now we are asked to find the range of x, so we have to eliminate 5 by 4. So in order to eliminate 5 by 4, we have to multiply it by 4 by 5. So we can write it as 2 multiplied by 4 by 5. Correct. So this gets eliminated and we are finally here with our range, that is correct. I hope you understood. So this is how we solve the inequality, such type of inequalities. Now let us move on to a very interesting question, extremely interesting question and extremely important question. This one question will clear your whole conception about mod. So the question is, give it a star mark. This one question, I am telling you, will clear your whole conception. Try to solve it. Pause the video and try to solve it. Done. Now let us begin with my solution. Let me begin with my solution. Okay. First of all, x can never be equals to 0, 5, -5. Correct. X can never be equals to -5. Why? Because if x is equals to -5, then the denominator is getting equals to 0, and as a result this is getting undefined, this is not defined. So one simple conclusion that we can make by looking at the inequality straight up is that x can never be equals to -5. Correct. Now if x can never be equals to 5, there will be two cases. Okay, so case number 1, x is greater than -5. Correct. X is greater than -5. So let us manipulate the inequality a bit. So x square minus 4, can we write this as less than 8 minus 4x multiplied by mod of x plus 5. Correct. Now for the case 1, we have taken x is greater than or equals to -5, so we can say that this mod will always be greater than 0, always, right? For this case, for case number 1, this one will be always greater than 0, so we do not have to open the mod with a negative sign or a sign change. So simply what we can write from here is x squared minus 4 is less than 8 plus x multiplied by x plus 5. Correct. Now if you 4x, if you do the simplification and you transfer the RHS to LHS, what you're going to get is wait a bit. Correct. Okay, so what you're going to get is 5x squared plus 12x minus 44 is less than 0. Correct. Now what you have to do is factorization. Okay, so after the factorization you are going to get it as 5x plus 22 multiplied by x minus 2 is less than 0. Okay, so from here again, if you solve this inequality, you are going to get the range of x as this. Correct. This is your range for x for case number 1. We are only discussing case number 1, so I am repeating the case number 1 again for you. So we have so the first conclusion that we made is x can never be equals to minus 5. Why? Because the denominator will be 0 and anything divided by 0 is undefined, so this whole inequality will be undefined. Correct. So there are only two cases possible, that is x less than minus 5 or x greater than minus 5. So first case we have taken as x greater than minus 5, and we have manipulated the inequality a bit, and we have taken the denominator that side and we have multiplied. Now it is time to open the mod. Now how will the mod open, with a sign change or not? Since x is greater than minus 5, so obviously x plus 5 will always be positive for this case, and the mod will open without a sign change. So and then we have just multiplied and simplified and factorized and got the range of x. So this was our case number 1, all about case number 1. Now the second case is pretty similar. Second case we have taken as x less than minus 5. So we have taken so this will be x squared minus 4 less than 8 minus 4x multiplied by mod of x plus 5. Correct. Yes. Okay, so now we have, it's time to open the mod. Now how will I open the mod? With a sign change or not? Definitely with a sign change, because x is less than minus 5. So since x is less than minus 5, this one will always be negative. So if this is negative, the mod will open with a sign change. So we can write it as x square minus 4 is less than minus of 8 multiplied by x plus 5. Correct. Correct. Now again you have to connect the dots that I told you. If x is greater than minus y, so x will be less, so minus of x will be less than y. Correct. So similarly, if you here also you can apply this logic, and if you multiply it and solve it, what you're going to get is, I'm directly writing the equation 3x square plus 12x minus 36 is greater than 0. Then factorize, now we have to take 3 common, so what we are getting is x square plus 4x minus 12 is greater than 0. Then factorize it, x minus 2 multiplied by x plus 6 is greater than 0. So now see, we are getting 2 here. Okay, so one thing we are getting is x is greater than 2, so this is not possible. Why? Because the case is true for x less than 5. We have already taken x less than minus 5, sorry, x less than minus 5, so x can never be greater than 2. I hope you understand. We, for the case number 2, we have already put a condition that x has to be less than minus 5. So if x is less than minus 5, so how will x greater than how will x be greater than 2? So this case is obviously what to say, denied. So another case that we are getting is x less than minus 6, correct? So if this is so our solution is x less than minus 6. So I hope that you have understood this question. Very simple but very important. Okay, so this is the question. We have not taken x greater than 2 because we have defined a definition here. Now one question that I want to give you for homework is another question, that is 5 minus x multiplied by 5 minus mod of x is greater than 9. Okay, so this is your homework question. So I have given you 2 questions as homework. So solve this, join the Google Classroom, and there you can comment down below or submit your solutions, correct? Now with this being said, our whole modulus is completed. We have covered the equality in modulus function and the inequality in modulus function. So okay, one thing now, I think today this much is enough, since this is the basic math. From the next lecture we are going to start sequence or theory of equations, any one. So I hope that you have understood today's lecture, and thank you for watching.